Check one, check one. 1, 2, check one.
Yeah, good. Can you hear? 1 2 1 2. Ah, I hear me. Thank you.
Check, check. I can.
Good morning, everyone. Welcome to the third day of the 17th edition of Salt March Media's Great International Developer Summit. Give yourselves a round of applause. We are thrilled to have such a dynamic and diverse audience gathered here today. On behalf of Salt March Media, I extend a warm thank you to each one of you today for joining us on this remarkable day. The first edition of GIDS was held in 2008. That year also marked significant milestones in scientific exploration. For instance, the Large Hadron Collider, the LHC, at CERN successfully circulated its first beam in September of 2008, setting the stage for groundbreaking experiments in particle physics and furthering our quest to unravel the mysteries of the universe. In that same year, new telescopes and techniques discovered the building blocks for life beyond our solar system. These events laid the foundation for a new era of discovery and innovation, symbolizing humanity's insatiable curiosity and our relentless pursuit of knowledge. Today, as we convene at GIDS 2024, we find ourselves at the forefront of a digital revolution, a revolution fueled by creativity, collaboration, and cutting-edge technology. GIDS 2024 promises an unparalleled opportunity for exploration, learning, and inspiration. With an extraordinary lineup of speakers and sessions, we invite you to delve deeper into the realms of software engineering, architecture, and innovation as we embark on a journey to unlock the limitless possibilities of the digital frontier. Now, let me provide you with a glimpse of what we've got lined up for you this year. We have curated an exceptional lineup of over 160 sessions covering a spectrum of topics from deep tech and architecture to ops tech and tech leadership to front-end and back-end development. Insights from over 100 speakers from around the globe sharing their expertise, experiences, and an expo featuring 31 partners showcasing cutting-edge technology, products, and solutions, including our platinum sponsors, Red Hat, Freshworks, Atlassian, Zoho, Work in Finland, Salesforce, Angel One, Target, Neo4j, Google Cloud, IKEA, and AWS. Our gold sponsors include Temporal, Arxesium, Wells Fargo, FM Systems, OpenTech, Tesco Technology, and DE Shaw India. Silver sponsors Apprise, Elastic, PingCap, Delta Technology Hub, ThoughtWorks, E2E Cloud, Couchbase, Snowflake, Goldman Sachs, and Manage Engine Site 24/7. And our bronze sponsors Cloudinary and Walmart Global Tech. Please take the time to visit our partners at the expo and gain insights into the latest advancements in the industry. Now, let me quickly step you through today's schedule. We'll start the day with inspiring keynotes. After that, we'll break for coffee and refreshments before diving into parallel sessions in 5 halls for the rest of the day. You can view the session timings and hall locations in your summit guide on the schedule banners placed outside this hall. We've allocated a 10-minute break between sessions so you can move between the halls easily. And now, let's get started on the learning. I would like to give the podium over to Scott Davis, who will be introducing our first keynote speaker. Please give it up for Scott Davis.
How is everyone doing this morning? Good? Yes? One of my favorite parts of this conference are thinking big thoughts. Thinking not about what you're doing on a day-to-day basis, but how you could be improving on what you do on a day-to-day basis. Not what you're doing today or even yesterday, but what you should be doing tomorrow as a software development professional. And I can't think of anyone who embodies that any better than Dr. Rebecca Parsons, CTO Emerita of ThoughtWorks. I had the opportunity to work with Rebecca for 7 years, and it was amazing. Rebecca has been with ThoughtWorks for over 25 years. As a software consultant, when I hit about 18 months, I'm expecting a gold watch. And to be with an organization for 25 years, think for a moment of the sea change that we've experienced in our industry over 25 years. ThoughtWorks released Cruise Control as an open source project back in 2001 that introduced us to the era of continuous integration, continuous deployment, and set the stage for DevOps, something that is still very relevant as we're talking about today. ThoughtWorks is where ideas like microservices were popularized and explained to the rest of the industry. And so for Rebecca to be here this morning talking about the architecture of generative AI continues that trend of having people who are deeply knowledgeable about our industry, but good human beings as well. And being able to explain the nuances of what you're going to be doing tomorrow and next week and next month and next year. So with great honor and privilege, I'd like to introduce to you Dr. Rebecca Parsons, CTO Emerita of ThoughtWorks. Thank you so much.
Hello, everyone. I've changed the title slightly because as I was working on this talk, it occurred to me that it's not just software architecture that is being impacted and will have an impact from Gen AI, but it's architecture more broadly. I want to talk about not just architecture or software architecture, but how architectures will support the deployment of Gen AI systems? And what are the implications on architecture from Gen AI, but also on architects? Now, some people from time to time have said that I don't like architects, that I have something against architects. That is completely false. I do believe that there are roles for people who call themselves architecture. And just because some people perhaps don't do the job in the way that they should does not mean that the job is not legitimate. And so I do want to talk about how this is going to also affect being a working architect. Now, one of the things I want to start with is the fact that there's so much hype. And I've been involved with artificial intelligence about since fire was invented, it feels like sometimes. And we've seen all kinds of AI winters. This doesn't feel the same. And I think there's some reasons for that. Even though the hype is absolutely enormous, what we have is a much stronger foundation to work from. Part of this comes from Moore's Law. Computers are faster now. Isn't that wonderful? Memory is cheaper. Isn't that wonderful? But also just the enormous amount of data. And we'll talk a little bit more about data. But it does feel like even though there are going to be people who disappointed because the hype is so great about what Gen AI can do, I do believe that we are not getting ready to go into an AI winter. It isn't AI autumn at the moment. Now, of course, with the pace of change, much of what I'm going to tell you is going to be obsolete on Monday. So, take it with a grain of salt. Seriously, though, I'm going to try to talk about this in such a way that maybe the tools are going to be different. Maybe new algorithms are going to be discovered. But a lot of the fundamentals, if you're talking about a technology that is legitimately called generative AI, it will still have some of these properties. Now, there are two aspects to working with an AI system: training and serving. And they're very different. They have different problems associated with them. There are vastly different use cases for even thinking about them. And this is also someplace where there are some pretty significant differences between what I like to call plain old-fashioned AI and what we're now calling Gen AI. So let's start with thinking about training. I hear from many people Well, my organization is special and we're big enough, and so we're going to train our own foundational model. I really would encourage you not to do that. The energy requirements are enormous. The data requirements are enormous. We don't need n number of foundational language models for n organizations. What we get with these foundational models, and I'm distinguishing foundational models, so that's going to be a reserved word here. The reason for that is to give you the basic natural language processing, the fluency with language, the ability to understand and parse a sentence and respond intelligently. And so there isn't a need for you to have a foundational model. Now, that doesn't mean you don't want to have a model that is instantiated for your context, but that's a very different thing than building a foundational model. RAG, for example, and I'll talk more about RAG a little bit later, is generally a much better option for trying to get some specific context from your organization into a model. Google's attempts to fine-tune their image model to make it a bit more diverse should help you understand that fine-tuning is not something you necessarily want to rush into, because it is not obvious how to do it right. So let somebody else do it for the foundational model. Now, this is one of those cases where older AI techniques are very different. The training requirements in many of those situations are much simpler, so you don't have these same considerations do not apply. And then what you do is you build on top of these foundational models whatever applications that you want to take forward. And that's what's going to serve up the model. That's when you're actually going to derive value from the model. It's whatever applications that you write. So how do we think about that? Well, you've got the standard questions that you're going to ask. Security is a big deal. Are you feeding in prompts that might inadvertently expose personally identifiable information? Are you vulnerable to particular kinds of jailbreaks that might expose information that you don't want to? And one of the problems that we have is, as the context windows have gotten larger, jailbreaking has gotten easier. They've already demonstrated that if you ask right in a row multiple times, tell me how to make a poison gas, tell me how to make a bomb, tell me how to do this, tell me how to do that, over and over again, asking questions, eventually it's going to answer. The context window is now big enough that you can steer the model to give you answers that it's not supposed to give you. Privacy and data protection. Of course, this is critical. And one of the sets of tools that are available are guardrails to help control what is going in a prompt, what is going out in an answer, so that you can protect. Latency. I've heard so many people talk about how frustrating it is now that everybody's using the free version of ChatGPT and waiting and waiting and waiting and waiting. And well, that's because everybody's trying to use the free version. They don't want to pay for the subscription service. And throughput. When you think about what is being intended with many of these applications, you're trying to increase efficiency and decrease the reliance on having to scale solely by hiring more people. That's not the same thing as replacing people, by the way. But in this context, you can't get that level of efficiency if you can't get the throughput. And finally, observability. This is something that This technology is not well understood, and we need to understand what is this model actually giving to our customers, to our users. And so observability takes on a whole new meaning, not just in support of latency and throughput, but also in, are we doing the right thing here? For those of you who know about evolutionary architecture, one of the questions both Neil Ford, my co-author, and I get asked is, what do fitness functions mean in the context of Gen AI? And I do actually believe that, particularly given the scale at which these applications are being deployed, being able to automate some of the checks that you want to put into that system is going to be critical. So I think we're going to see a lot of evolution of monitors and static analyzers and other such fitness functions to help us keep control of our AI warloads. And maybe I ought to say before I go on, I do not believe that in my lifetime, the world will be destroyed by a paperclip optimizing AI, which has decided that humans are taking up too many resources that could be used to make paperclips, and so they wipe out the human race. I do not believe that is in our future. That doesn't mean I don't think that we have to be careful, because there is still a lot of uncertainty on how these things actually work. What have those new models actually learned? Now, we were talking about some of the illities. Let's talk about some of the biggies. Hallucinations. I have to tell you, this is a feature, not a bug. Think about what we are asking a generative AI system to do. We've loaded up all of the published works of William Faulkner as one example, and we ask it to create a new short story in the style of William Faulkner about the southern United States and a particular event. We are asking it to make something up. That is the whole point, is to take what is there and put something new together. That is the whole point. So to say hallucinations are bad is a problem, because that's what these systems are about. That doesn't mean the hallucinations aren't a problem. Sometimes they are factual, as Air Canada learned when their customer service chat bot created from whole cloth a bereavement refund policy. And the courts in Canada said, sure, Air Canada, you've got to respect that, because it was your system that told your customer that he deserved the money. It made it up. My favorite hallucination so far, this happened internally. We have a collection that we take over the years and have our consultants tell us, what are the technology stacks that you've used with our various clients on various projects? And we've been collecting this stuff for probably 6 years. And one of our guys loaded this up into, I believe it was the Llama model, and asked the question, what was the most popular technology stack in the year 2022? And the answer was a short story. The concluding paragraph of this short story was roughly paraphrased, I am not a farmer sowing seeds. I am an arborist planting a tree and nurturing it so that in 100 years, it can host a village. That was the answer to the question of what was the most popular technology stack in the year 2022. We got a ways to go. Now, we have to remember these models want to be helpful, and they try to be agreeable. And they are very sensitive to how you prompt them. If you prompt a model as if you're talking to a colleague, you'll get a very different answer than if you prompt as if you're speaking to an assistant or someone you think is not as good as you. It will answer differently because it is trying to respond not just to the words, but to that sense. And that's part of why it makes things up in the way that it does, because it wants to give you an answer, and it's designed to create things. And so we really do have to deal with this issue of hallucinations. And yes, there are some things like temperature control and all of that, but fundamentally, at least for the time being, many of these things shouldn't be used without a human in the loop. There was a case, again, in the United States. A lawyer, stressed to get something before a judge, asked ChatGPT for help, and ChatGPT made up case law. And the lawyer didn't check and turned it into the judge. And when the judge was sanctioning him, he initially tried to throw his assistant under the bus, but eventually did admit that, yes, he was the one that used ChatGPT, and he was the one who neglected to actually check whether the case actually existed. So we need to keep a human in the loop on a lot of these things, which, if you go back to what we're trying to solve, people using this, for example, as a customer service chatbot, we have to think about that more carefully. Do we need to be more careful about what prompts we allow in while we're still trying to figure out what's it really going to say? Which brings us to our next problem, non-determinism. You can ask exactly the same question twice and not get the same answer. Now, the problem with this, particularly with the way so many different organizations are experimenting, is how do you explain to your chief financial officer or your chief operating officer that this system isn't going to always give the same answer to the same question? Non-technical business people have a relatively simple model of how technology works. And this is similar, for those of you who went through this, with the issue of eventual consistency. Trying to explain to maybe the general counsel of an organization that, yeah, eventually all the data is going to be the same, but you won't necessarily be able to look right away and get the answer you think you're going to get. Explaining that was a real challenge. We have this same kind of challenge with non-determinism. We have to be able to help our business leaders understand the risks that they're running with using this technology. And oh, by the way, I'm not trying to be a down on this technology. I think the potential is enormous, and we'll talk a little bit more about that. But we have to be realistic about where it is right now. And right now, it's non-deterministic. As I alluded to earlier, it's not difficult enough to convince a model to start giving you inappropriate responses. I found the short story response amusing, but it could just as easily been something that some people might have found offensive. So these models have the capacity. And when you think about it, think about how these models are trained. They're trained on this immense corpus of literature over the years. Think about your experience reading fiction. What percentage of the discussion is about the good guys versus the bad guys? We actually know a whole lot more about the bad guys. And that doesn't bode well for trying to get responses that are appropriate for polite society. Okay, so let's stop talking about that stuff, let's start to get to architecture. As I said, as I was looking at this talk, I decided it was important to think more broadly. And so this is a conceptual stack of the various elements of a Gen AI system: hardware, infrastructure, the model itself, the tools that you use, and then the applications. And I'm going to take each one of these layers and talk a little bit about it. Let's start at the hardware. As I said, part of the reason I don't believe we're heading for a catastrophic AI winter like we've had in the past has to do with hardware. But that doesn't mean that there isn't a lot of specialized hardware here. Everybody knows about GPUs, and hopefully some of you were lucky enough to have bought NVIDIA stock long enough ago that you're sitting pretty right now. But there are also new chips that are being designed. The TPUs are specifically designed for training, and the LPUs are specially designed to support more broadly natural language processing. If you're trying to serve up multiple models, and think for a minute how many parameters we're talking about for a given instance of a model, and therefore how much memory that takes. And if you've got several specialized instances of the model, you're going to have to be swapping those things in and out of memory, which is part of where your latency problems come in. So they're even doing special cache designs to make it easier to swap out models and decrease the latency if you do need to swap a model out of memory and swap a new one in there. Some of you might work for chip manufacturers, and you all should be worrying about these things. The vast majority of us, let somebody else worry about it. We'll just use the hardware that's there, but it is worth understanding what the capabilities of these various specialized hardware components are so that we can ensure we're using the right thing. The next question, where are you going to run it? You've got a choice of a publicly hosted LLM. If you're a relatively small organization, this is probably what you're going to use. You're probably going to just figure out how it is I can use this in such a way that I will not disclose my client data and I will not disclose my intellectual property. But for a lot of organizations, that's simply not possible. But on-prem here does not mean you have a physical machine sitting in your room. This might be you're hosting it in your own cloud instance. It might be on-prem, but it might be your own cloud instance. There are lots of reasons for doing this. It may have to do with laws about where things can be hosted and where data can flow. It might be security. There are all kinds of reasons you might decide it's all fine and good for others to use OpenAI's model or Google's model, but I'm going to use one of the open source models that are available. I'm going to host it myself. And that way, I know what's going into it. I know how my data is being used and whether or not the training, what is happening with the inputs that I'm using with respect to training the model. And then the second question is, do you want to use just one of the foundational language models out there, or do you want to use one of the other variants? The image generators, for example, are quite well known, but there are other specialized models that are using the same kind of technology. One of my personal favorites is there is a model that takes as an input a linear string of DNA and outputs target three-dimensional structures of that protein as it's been folded. And it's been trained on the relationships between DNA DNA sequences and three-dimensional models, but it's the same basic problem. I'm looking at what are the three-dimensional configurations of all of these related sorts of DNA strings, and what do I think a potential is for the three-dimensional structure of this one I've never seen before. The value of this model is it can dramatically reduce the cost of drug discovery. And part of the problem that we've had in the past with dealing with a lot of diseases that have been around for a long time is the pharmaceutical industry doesn't really have the financial incentive to invest that much money on some of these diseases. If we can dramatically reduce the cost to come up with drug candidates, we lower the cost of developing drugs and we increase the probability that we will actually start to attack some of these other diseases. A model like that is not going to help give you a William Faulkner story, but it uses the same basic underlying technology of training up a model in such a way that it can generate new instances based on the corpus that it has been trained on. So, critical question, where are you going to run and what kind of model are you going to use? And then we get to the model layer. Now, one of the things to realize, as step one, these models have essentially been built using the same data. They've all scraped all of the publicly available information, whether it be code or books or movies or photographs or Reddit posts, all of those different things. There is usually some kind of specialization level where a human gets involved. And obviously that's going to lead to some differences between the models because the humans are different. And the humans, even if they're given the same instructions, are not necessarily going to do exactly the right thing. So even though they have much the same training data, these models don't all behave the same. And you're going to want to try some of the different models that are available, if you can, to try to see which one is most appropriate for your use case and for your organization. You may decide you want multiple models. Sometimes that's obvious. Maybe some of what you need to do requires an image generator. And other parts of what you need, you want more text generation. So you might choose two models just because you have different uses you want to put them to. The next question you want to ask is, do you want an open source or a closed source model? There's actually still a lot of discussion going on what does it mean to open source a model? Is it the algorithm? Is it the parameters? Is it the training data? And there's a lot of effort being put into trying to understand what should you open source if you were going to open source a model. That being said, there are actually a significant number of open source models out there. The last estimate I heard was that it was those models are about 18 months behind the best of the closed source models. We talked a little bit about this on the previous slide. Is it a general purpose model? Are you looking for that general language capability, in which case you want one of the LLMs? Or are you looking for something more specialized? The next question is, do you actually want to build your application that is such that it is agnostic about which model it uses? This is roughly analogous to the question of, do you want to run multi-cloud, or do you want to specialize yourself to a particular cloud so you can take advantage of whatever specific features exist in that cloud? Because, as I said, these models aren't all the same. And so they're not necessarily going to respond in the same way. You may decide that you want to use different models for different purposes, you might, in fact, decide you want to be able to switch among models. And there are some tools that are available to help support switching amongst models. And then there is, again, the question of fine-tuning. Do you actually want to take one of these models and fine-tune it? Or do you want to use some other technique like RAG? Now, one of the more disturbing things I've read recently is that the model trainers have decided they're running out of data. Now, if you think of all of the estimates on how much new data we generate on the internet every single solitary day, the fact that they think they're running out of data is concerning. And so what they want to do is they want to start generating synthetic data using the large language models that they are then going to train the next generation on. That isn't an idea that I'm real comfortable with. You're taking something that, sure, it has a level of creativity in it, but most people, after they've seen some amount of responses from these models, they can look at some text and say, yeah, ChatGPT did that. If we then start training the next generation of model that ChatGPT is going to access using output that everybody says, ooh, that looks like something ChatGPT did, we are going to start to degrade the quality of the output. We don't want that. In addition, like any reinforcement learning system, any biases that exist in that data, in the training data, are going to be reinforced and amplified if you start using synthetic data in the training. It's bad enough that just using those models does tend to amplify whatever characteristic, whether it be desirable or not. But if we're then going to use this to train the next generation of model, we run a risk of degrading the quality of the output of the model. So I'm hopeful that they're going to do a lot more research on, is this really a sensible approach to use this level of synthetic data? Now, one of the puzzles, and I haven't found an answer to this yet, so if anybody has heard this, I would love to hear it. A while ago, Sam Altman was reported as saying that he felt that the next significant leap in the power of the model would not come solely from an increase in the number of parameters. And much of the increase that we've seen in the past has been attributed to the fact that there's been an enormous increase in the number of parameters that the models can hold. And so the implication was that they're going to have to figure out, how do we supplement the current models and the current algorithms that work on those models to get that next leap forward in the power of the model? My hope is that if you take, gee, we're running out of data, with, gee, we need to rethink the problem a bit to get more power, maybe those things will cancel each other out. But this is something that I think it's worth people keeping an eye on. If we're actually running out of data, given the rate the world creates new data on the internet, that's a scary thought. There's all different kinds of tools that exist out there for different purposes in working with these different Gen AI systems. We recently put out our 30th edition of the Technology Radar from ThoughtWorks, and about a third of the blips had something to do with AI and Gen AI, and many of them were tools that will help you perform various tasks. Obviously, there's the coding assistants, whether it be something like Copilot or whether it be something like the JetBrains enhancement of their IDE. An interesting thing around this in terms of coding assistance. One of my contentions is that if we're going to actually take advantage of generative AI, we have to fundamentally rethink our processes and how we do our job. Rather than saying, okay, these are the steps I follow, what can Gen AI do? We need to look instead at, this is the outcome that I want to achieve. How can AI help? In terms of category of tools, though, we obviously have the question answerers, the chat GPTs of the world. Also, documents that answer questions, which is a very popular application I will talk more about. There are tools out there to help you build guardrails for privacy protection and monitoring the flow of data. And then, of course, we started with DevOps, and then we had MLOps, and now we have LLM ops. But it's just as important in dealing with large language models as it is anything else. We have to know how to deploy them. We have to know how to monitor them. We have to know how to fix them when they go wrong. We have to know how to evaluate how well they're working. And I'll talk more about that in the last section. And then there's applications. And of course, there's an enormous range of applications. We've been using AI for decades. Part of what's different now is that most of the AI you've interacted in the past with, you didn't think about the fact that it was AI. For decades, fraud verification on credit card transactions have been done with a neural network. You've been working with an AI system every time you use your credit card, but you didn't know it, and you didn't have to know it. One of the interesting implications, particularly of ChatGPT, is we have people who are interacting directly with AI systems that aren't AI researchers and that aren't computer scientists. We have lawyers and doctors and marketing people and construction workers, and pick your favorite. These are people who are using this incredibly powerful technology. I was speaking to a colleague of mine, and he said, yeah, I was in my doctor's office, and she says she's been using ChatGPT to look things up. And he was horrified and said, please tell me you checked on the answers that it gave you. But it is so easy to access this technology. I think that's both wonderful and terrifying. It's terrifying because people don't necessarily know the risks that they're running if they take things at face value. Case in point, lawyer who got sanctioned by a judge because he didn't check the ChatGPT's work. But wonderful because we don't really know the impact that this technology is going to have on all of these different applications. And having a broad set of people who are thinking about how can I use this technology to make my life better, that has the potential to open up a flood of innovation. I've always been very skeptical of innovation centers of excellence, where you have these people, who are supposed to sit around and think great thoughts. I would far rather crowdsource ideas. And sure, eventually somebody's got to decide which ones to fund, but you want to bring them from as broad a place as possible. And the democratization of AI that has happened as a result of things like ChatGPT radically expands the source of ideas and how we might actually use this technology. But I put some example applications up there. Obviously, apps supporting software development. And this is not just coding assistance. This can be generate me an outline of an organizational change management strategy. Give me some ideas on how I might structure a workshop. Show me how I might test an application with this particular features. These are all things that people are trying to do right now in supporting the software development lifecycle. We've probably heard the most about the customer service chatbots, particularly when you have things like Air Canada and their loss in the legal case. An interesting one that I've seen is to help the marketing department. There are applications that will generate comprehensive marketing plans. They will generate an image to support the mood that you want to set if somebody's looking at a display ad. They will generate an elevator pitch or the text that should go next to particular images to help sell your product. Now, of course, I would not take one of these and immediately send it to the metaphorical printer. But one of the nice things about these systems is they give you a place to start. One of my colleagues often has a horrible case of what I like to call blank paper disease. He's looking at a blank screen and has to write something and just can't get the first words out. He started using ChatGPT. And what's interesting is sometimes he really likes what's there and he just sort of fixes it up a little bit. But it's not all that uncommon that he hates what comes out. But what ChatGPT has done is put something on the screen. And even though he might delete the entire thing, it's gotten him over blank screen disease. Whatever works. One of the more interesting applications that we're seeing a lot of is effectively a document that answers your questions. So think about your employee policy guide. Isn't that so thrilling to read? But instead, you can load, through some of the techniques we'll talk about, that employee resource guide into a document answering system. And then you can ask, what is the specific eligibility period for the medical plan? And it will spit it out. And some of the better ones will not only spit out the answer, but they will give you the reference to where it appears in the guides, so you can actually go check it. People are also using something similar to this to start to analyze legacy code. You load up the legacy code and then you start asking questions about how it works, about how the information is flowing. Because what's one of the biggest problems of dealing with these legacy applications is you don't really understand how they work. And I'm beginning to think that these code models are actually better at explaining code than they are at writing it, which might not be a bad thing, by the way. One of my favorite applications, this is something that has come from ThoughtWorks, but I think it demonstrates how you could integrate these models into a broader application. And Jugalbandi started life as an application here in India. The front end was a speech-to-text translation system that supported the Indic languages. The last number I saw that it's up to 11, but that was in January, and they've actually gotten much more efficient about supporting a broader class of languages. And it translates questions from people who are asking about the various welfare schemes that are available in India. And so consider a farmer somewhere who's using WhatsApp, and he can ask the question, what housing schemes am I eligible for? The speech to text will translate that. They will translate it into the base language of the documents that have been pulled from the Indian government website, using RAG to find the relevant policies, and then engage in a dialogue asking questions. Well, do you fall into this category? What is your situation here? And then presents to the person, this is what you have to do to be able to exercise your rights for this particular scheme. They've expanded it to include some other things having to do with the legal system in India. But you have RAG, you have speech to text, you have integration with various schemes out there where they can validate things. So it's not just ChatGPT. It's not just you have this gigantic model and you've got this very simple prompt interface and you're going to talk to it. You have a model that can serve as a critical component within your organization's IT assets. Okay, so let's talk about some patterns. Software architecture. This is a non-exhaustive list, but I think all of these have some relevance. If you're just going to serve a model that is going to ingest a prompt and respond to a prompt, a serverless architecture is absolutely the right way to go. And if you do some research, a lot of the performance improvements and tests and strategies are based on using a serverless architecture. But when you start looking at broader integrations, you might want to start considering a microservices architecture. If you think back to that Jugalbandi example, you've got lots of different moving parts going on there, and the model is clearly a critical part of that. But you've got different kinds of integrations to worry about, and so you'll probably want to consider to break up some of those activities into a microservices architecture. One of the more interesting things that I've seen with respect to privacy is pushing more and more of the serving of the model out to the edge. We'll train the model centrally, and maybe we'll use some of the techniques that are available to scale back a model. So, you're not trying to send, a trillion plus parameters to your poor mobile phone over your data roaming, which would be frightening. But instead, cut down the model, and then the interaction between the user and the model never leaves the user's phone. And so they have control over their data, but they're still able to take advantage of the power of the centrally trained model. So this is something we're starting to see more and more of, and I think that's going to continue. Now, I've talked about RAG. How many people are familiar with RAG? Okay, so a lot that aren't. RAG stands for Retrieval Augmented Generation. And conceptually, what you do is you've got this foundational model. Remember, that's my reserved word for what understands, in quotes. It's very easy to anthropomorphize these models, but it interprets the prompts and responds to those prompts. And you augment that foundational model with specialized content. Maybe what you have is your set of coding standards. I know of one particular application of this. A colleague of mine put together something. It was still a chatbot, but it was augmented with all of his individual writings. And so he used the RAG technique to effectively embed all of his writings. And then he had effectively a language system that would respond in his personal style. We all have a personal style. There are words that we use more commonly than others, more frequently than others. There are words that we don't tend to use at all. Some people always speak in very short sentences. Some people speak in much longer sentences. Some people have very plain language. Some people have very flowery language. And this chatbot responds like Mike. And all he did was use this technique to load up his writings. And now you have a melding of the language capabilities of the foundational model, but it is biased towards using Mike's voice. You can do that with all kinds of documents. I saw a recent paper where some people have also augmented the standard embeddings that you get in RAG with one example. In fact, it was an org chart. It was, these are the different organizations, the entities that exist within my company and how they relate to each other. And so the questions can be put into the context of where the question fits in the hierarchy of the organization. So there are all kinds of different things you can use this RAG technique for. Another very powerful software architecture approach is integration with other systems. One of the things I found reassuring about how Google was approaching some of its chatbots is when it came back with an answer, it came back with a link to where it found the answer or what it used to create the answer. And it made it a whole lot easier than to be able to check and see, okay, well, does this link exist or not? Because, ChatGPT makes things up. There's a Guardian reporter who has gotten multiple queries about how come I can't find your article online? And ChatGPT had properly identified this reporter as someone who wrote on this particular topic, and they made up the title of an article. And this one reporter got multiple requests like this. So having the ability to easily cross-check something is just one possible integration. Jugalbandi and the integration between the language model and the speech-to-text is another example of that, but there are numerous ones. Now let's talk about multi-agent systems. Everybody loves multi-agent systems. They're all the rage. An agent, very simply, is something that can take action outside of its context. And there are easy ways to do this, and there are hard ways to do this. And when you are looking at a multi-agent systems, particularly one where the agents act relatively autonomously, you have just bought yourself all of the potential problems of any distributed system. And you got to figure out how to address all those problems. So the topology of your multi-agent system matters. You might decide that you can conceive of a pipeline-like workflow where a problem is addressed in sequence by multiple models before it comes out at the end. By definition, that's a multi-agent system, but it's a relatively simple one to keep control of. If you start to get multiple layers, if you start to get lots of competing approaches to the problem, it's much more complicated. And you have to worry about the granularity of these individual agents. If you make them small, what does that mean? You probably have more of them. But if you make them small, it might be easier to understand, are they actually doing what I want them to do? Back when I was dealing with AI early on, there was something called a blackboard architecture. And that this idea has come back into favor. And conceptually, what you have is you have a blackboard. And I write a problem on the blackboard. And all of the students, the models, the agents, all look at the problem and decide, I know how to solve that. and they go off and come up with an answer, and they write their answer up on the blackboard. And then when we've either got, sorry, I'm stumped, or an answer from all of the different agents, then you can decide, do I want to take a consensus answer? Or do I like this answer better for whatever reason? And so that's one way also to approach a multi-agent system. But my recommendation is, if you are early in your journey in dealing with Gen AI systems, try to keep it simple. One very simple use, and I'll talk a little bit more about this later, is to have one model check the answer of another model to decide whether or not it's a good one. That's a relatively simple interaction, and you won't get into too much trouble trying to approach that. But let's not make this problem any more complicated than it already is. Again, some of the prominent abilities. Of course, this is a non-exhaustive list, but I do think one of the important ones that we have to at least understand what risks we are running is the non-determinism. We talked a lot about those other ones, but I do want to remind you that latency is a big deal. Just because our computers are faster than they were doesn't mean that they can respond at the speed that we would like them to respond. And that's something you have to take into account depending on how you're using the AI system. And I can't reinforce enough, yes, we do still have to care about observability, even if we don't really understand what it's doing under the covers. Now, one of the big problems that we're dealing with at the moment, 2023 was the year of the proof of concept. All kinds of organizations did all kinds of POCs across things that would go to their customers, or things that would help support customer service, or things that might help their sales organization, or things that might help finance. We've got POCs all over the place. 2024 is the year they're trying to put those things into production. It's not going so well. The last number that I heard was in the high single-digit success rate, roughly 7%. That's pretty bad. Now, the kinds of problems are not surprising. We all know how easy it is to manually fix a lot of things when you've got a small set of users. These systems are no more immune to bad data than any other system is. And the fact is, most of our organizations, our data is not in a state that it can be properly processed. And so often what these POC to production failures are highlighting is just how bad our data is. And so you have to go back to, okay, well, what do I have to do to clean up my data, to make sure the right people can see it and the wrong people can't, to make sure I know what it is, to make sure it's high quality data, to make sure ... Another part of this is, again, with a POC, cares about having a nice automated flow to production. We don't need that for a POC. Well, you do need it if you want to put these things into production. And so a big problem that we're dealing with this year is, how do we turn these POCs, and many of them have been quite successful in terms of validating their business case. What do we have to do to actually get them into production? Now, what about the poor architects? Well, it was bad enough before. When you think about the number of architects to the number of delivery teams, let alone the number of developers, the poor architects are vastly outnumbered. And now we've got coding assistants that are churning out more and more and more and more code. So we've made the problem for architects a whole lot worse. And oh, by the way, for things like refactoring, one study that I saw that was actually quite well done, the probability that the coding assistant got the refactoring right was 37%. That was the highest of any of the code models that existed. Now, how long do you think you'd keep your job if you got it wrong 63% of the time? Probably not very long. But what about coding standards? What about the enterprise patterns? How do I keep the integrity of the overall vision when I've got a code model spewing out code? And so we've made the problem for the architect much worse. But there are ways to handle it. First, let's talk about testing. Ponder for a moment, how would you write an automated test to test the validity of a non-deterministic system? There are actually some very well-developed metrics for things like natural language translation, but those metrics have not proved useful in evaluating the quality of some of these models. We're still playing with lots of different ways to validate this. Some of it is asking the language model to suggest tests that you might then run against the other language model. This might be that paired language model where one model checks the answer of the other one. We're also seeing a lot of red teaming going on in terms of trying to expose particular kinds of vulnerabilities in these systems. This is exactly the same kind of red teaming you see in security, except it's targeted at how can I make the large language model do something it's not supposed to do. And jailbreaking is, again, something that is getting a lot of attention. As I said earlier, given the size of the context window, we just can't handle it. Standards, we can use techniques similar to RAG to load up what our enterprise standards are, so the model won't generate stuff that we don't want it to. And that's just one of the approaches. But AI and Gen AI are completely reshaping the entire software delivery process. And we need to think about what that means for our jobs, and we need to think about what that means for the jobs in 20 years. And as a reminder, this will be all out of date by Monday. Thank you very much.
Thank you, Dr. Parsons, for your thoughts and for coming all of this way. Our next keynote comes from founding member of Zoho Creator, playing a key role in evolving the products from his first line of code to the transformative platform it is today. Here to show you the power of owning your tech stack, please help me welcome Charles Adekalam. Let's give Charles one more round of applause. Charles Adekalam.
Thank you. Good morning. I'm Charles, the Director of Product of Management in Zoho. So Zoho was founded in the year 1996, a quick intro about Zoho. And we have about 55 plus business softwares. We call it as the operating system of business. So you have a business, you can run your entire operations by using multiple applications back of Zoho. So Zoho division was started in the year 2004, and we have more than 55 applications, and we are about 15,000 employees worldwide with 2,000 partners of Zoho worldwide again, and we have over 7 lakh organizations using Zoho across 150 countries, and we have more than 10 crore users, end users, using one or the other Zoho products. And we were the first self-funded, bootstrapped privately held software company to cross $1 billion of revenue from India. We did this last year. So in spite of all these things, we have a very important or a key thing at Zoho. This is very important for us is privacy. It's close to our heart. Even when we started in 2004, this has been one of the key aspects for all the apps that we would want to do this actually. So this is what we tell our customers, that we don't own the data, but they do. And we will never ever sell customers' data because it is their data. And we will never display any advertisements to the customers, to our customers. And we will never do any direct or indirect. We will never engage, even in another division, we will never engage in a ad-based business model. And we will not use customers' data and try to get a revenue elsewhere. And also, we will make sure that we will not have any third-party trackers like Google Analytics or any other thing on our website. You can go to our website and check for a privacy report. It will say 0 trackers. So this has been our important thing all along these years of building Zoho. So this is possible only if we were to own the full stack by ourselves. So where we are not dependent on any other stacks, because that's how we will get the control. So all the applications that you saw are built on the same technology stack. So I'm going to quickly go through each of these stacks. So starting from the applications, and then we have the microservices that powers up the applications. Then we have the platform that powers up all these things. So usually when we talk about the platform, it's about the software, about the hardware, about the networking, and the data centers. So people generally don't talk about all these underlying things, and generally they say as a platform. But let's see each of them actually. To start with the data center, back in 2004, right? There are very few cloud computing vendors, and we didn't have much of any public cloud computing as well. Very limited. Even today, there are hardly 3 or 4 major vendors there as the public giving public cloud support. So the convention was to go for you build any product on the cloud, you have to go and build on the public. But back then we took a conviction, we were convicted that this is going to be for a long haul, and then we built deep technology expertise on the data centers, and then we built on our own. So today we have around 16 data centers worldwide, and if you see in each of these regions, we have the disaster recovery data centers as well, coupled up with each other. And moving next is the network infrastructure. We own the networking infrastructure as well. So we have a dedicated Zoho acceleration network where it helps reduce the latency. And we also have monitoring networks. We have the point in positioning network, which helps in very less hops. Usually when it goes from a customer to your server, there are a lot of hops that needs to be done. And we have purpose-built POPs all around the world, which will help reduce these hops. And moving next is the hardware infrastructure, where we make sure that we go down to the metal, like be it a load balancer or a firewall, or even if it is an application specific IC. So we have our own design of the system. So we basically have customized deeply. We have taken the Linux operating system and we have customized deeply and put it along with the hardware. And moving up the ladder, we have the software infrastructure. And if you look under the hood of a software infrastructure, so we have the database layer, which we have our own custom database with a unified data model. Because we serve business applications, we need a lot of data pillars for these business applications. Say like for a CRM, we need customers. For a HRMS, we need the employee data pillar. So these are the data pillars that power up these unified data platform, and these data pillars have to give a single source of truth, and these data pillars have to be interconnected with each other, which is why we had to build our own database, and they are all seamlessly integrated as a single unified data model. And then about the database itself, we have numerous custom database ranging from the columnar to time series and whatnot. So we have tons of customized database that is very specifically needed for each of these business applications. And note down that like each of these custom database are not only at the software level, but also at the hardware level, they are heavily optimized. And we have a unified file system that powers up our work drive that is also used across all these applications. And we have very customized application servers that gives you a high performance computing needs. And also to end up, we have the application firewalls, which is very customized to add more security. So that's up with the software layer. We also have our own encryption at rest. That's a very customized one. And all these things are homegrown. The point I'm trying to drive is that we are not dependent, or we don't depend on other vendors, primarily because we consider the privacy to be core of our DNA. And next, moving on to services, of course, we do a lot of services. There are tons of microservices that power up these applications, ranging from AI to audio video conferencing to the meeting bridge, the telephony bridge, and so on. There are a lot of services that we have, and that goes very wide and that goes very deep as well. And these things we are, especially on the AI front, we have a lot of patents that we have done and for the past several years. And one of the key important thing that I want to talk about AI is that we make sure that we don't touch the user data to train the AI model so that another business user can make use of it. That is absolutely no for us. So, and also we also gracefully integrate with other GPTs so that customers can make use of the publicly available GPTs. And finally, coming to the apps. So all these things power up, and then the application layer sits on top of these things. So we have applications that can run a company, and you name a software category for businesses, and then we would have software for that. And why does it matter actually? Okay, so why do I have to? Why is it that like we own the entire stack? It is because we want to make sure for the customer we give a very superior customer experience. So how do we give a superior customer experience? We can give a superior customer experience by unifying everything together so that we build in a single stack. When we say it's a single stack, it is not a monolithic architecture. Of course, we have a very distributed, but then we make sure that the entire tech stack is owned by us. And then it also helps us to give a better performance because we don't have to rely on other people for the performance. So we make sure that we work on all these things by ourselves. And then we have a seamless integrations together. So if you are a startup, probably for MVP, maybe you can rely on the public cloud. But beyond a certain point, it is better to go through all these things and then build up on your own. So because if you are out for a long haul, this is really, really important. And most importantly, this ensures that we deliver a certainty for the customers. So because we control all the aspects of these things, tomorrow if something goes really wrong, then we own it up. We make sure that we give the highest priority, or we move up the resources and then make sure that things are up again. Okay. But if it were for a third-party vendor, then we'll have to rely upon them. Then everything goes for a toss, maybe a downtime or a performance issue or whatnot. So we are able to make sure that we deliver a certainty to the customers because we own up the entire stack. And coming back to the tech stack, we have something for the developers as well. The developers. So we have opened up the top layers of the stack for the developers so that, and you have to note that all these things are purpose built for businesses, okay, for businesses, which means that we have the expertise or we have the technology for the things that are very specific to a CRM industry or for a manufacturing industry or for any department, for a finance, for example, for a finance industry. So we have, since we have the business applications spanning across the organization, we have built that expertise, and then we have made sure that we are exposing them out for the developers on these top 3 layers. And we have the Procode serverless development platform that we have is the catalyst. And starting with this software infrastructure, we have all these things that we have opened up, similar to, you can consider this similar to the AWS stuff. And we have the microservices as well opened up. And this is pretty much the architecture of the Zoho Catalyst that we have as a serverless Procode development platform. Then we have another powerful low-code development platform, which I'm heading. We started this back in 2005. And as I told you, we have 55 plus applications for all the business needs. But then what if there is a unique need that needs to be built very specifically? Because businesses are generally very unique. They want to have that secret sauce within themselves, which are unique from another company. Probably that's what will give the secret edge, or that is what will give the competitive edge against the others. So if they have to build, say, a custom ERP for them, okay, what do we have to do? So we have made sure that we have abstracted all the layers underneath, from microservices to software to everything. And then we have opened up just the application layer in a very visual way, where you need to write a very minimal code in a very efficient and a very faster way. So in general, if you have to write a custom application, you'll have to deal through all these things. Actually, you need to have take care of the back end, you need to take care of the front end, and so on. So using Zoho Creator, since we abstract all these technologies, it helps you to focus on the business logic, and it lets you to write the code only when it's absolutely necessary. And it is for everyone. Even if you are a pro developer, it will make sure that it will help you deliver your projects very fast. If you're an IT developer, maybe you are swamped up with a lot of projects that you can't handle, and you can easily deliver the projects. And if you are a citizen developer, you can quickly empower yourself using Zoho Creator. And to summarize, coming back to the tech stack, we believe that all these things are interconnected and they're extendable as well. And that's why we took this full stack approach. And what we hear from our customers is this, that there is a peace of mind, because we have heard that customers really are after us because we are able to provide this full stack approach, and we are able to provide them a very, very simple and an integrated way of the business applications. Thank you.
Thank you so much, Charles, for your insights. Let's give him one more round of applause, please. Our next keynote comes from a Chief Technology Officer app. His expertise spans a range of e-commerce and financial technology domains. Please help in welcoming technology leader Yotiswarup Pairetukar.
Good morning, everyone. So I have 15 minutes. I'm going to cover engineering elements in doing high-scale broking. So I'll start by setting context about the domain, what we do. I'm going to talk about only 3 design patterns that we employ and 3 choices that we have made in our tech stack. So this is our app. It's one place for all your financial needs. So we sell stocks, mutual funds, loans. The key things to note is there are a lot of prices here. They change multiple times in a second. And when people make decisions, they look at tickers, different tickers, and make decisions. So it's very important to get the prices which are fresh right onto the apps. People also find signals from other places, like near real-time insights that we bring out, like what are the most what are the stocks which are being bought most right now? We have about 22 million client bases, customer client. We are second in terms of the number of active clients on NSE, the largest exchange in India. In terms of scale, we onboard a million customers every month. We touch about 10 million orders in a day, and our traffic at 9:14 is 0, and 9:15 is 3 million requests per second. So it's a pretty steep ramp. So today I'm just going to focus on equities trading and what goes in building such a system. In terms of the mechanics, this is a timeline of prices of stock X. This is a platform where people can buy and sell the same stock at various prices, and a match happens when a buy and sell order are in close proximity, both in time and price. Right, you want to buy something, and the highest price that you want to buy it is more than the lowest price that someone is willing to sell something at. So we enable the marketplace. So what goes in here? First thing, prices need to be piped real fast to the app. Once someone places an order, those orders need to go and stand in the queue as soon as possible. Right, fast wins. Once someone does an order, then there's a lot of accounting that happens in terms of shares and funds, which then needs to be reflected onto the customer. This includes things like risk management. And finally, the order status changes, because whether your order gets filled or not depends on other people in the queue. So whatever happens, we need to pipe the information back to the customers very quickly. And all this needs to work in the face of patchy networks, server failures, or earthquakes, right? And since we are a regulated entity, we actually do DR drills quarterly. That means someone from the regulators comes to our office, starts removing wires, shutting down things, and still sees that things work. So just to emphasize, right, there are three ways to make money in equities trading. If you've seen the movie Margin Call, you know. If you haven't, you should go see it. Be smart, be fast, or cheat. So we don't allow customers to cheat. So the way to people make money is they are smart and they are fast. And the platform that we do um, basically pipes actionable insights to the customers very fast, and whatever actions they want to do, we execute them in a real time fashion. And the patterns that we employ, the engineering that we do, is all in the service of this. So this is a short demo of what we're talking about. This is a trader. He's going to look at Reliance, the price charts, and this is something called as an option chain, which has various contracts of Reliance, various dates, various prices, and then he's going to start placing orders, right? And this is someone who's actually doing this, so you can see how fast is placing orders, right? There's muscle memory in what they look at, various prices that they look at, and they want to grab opportunities that they see real time. Once you click orders, you also want to see what's your PNL, which is again reflected real time. All this is happening by us, the app talking to our backends talking to the exchange, WebSockets piping back information back in, and everything happening nicely on a rosy day. So 3 design patterns. The first is eggs and basket. The basic problem we're trying to solve here is how do we ensure systems are available if there's a fire in the data center? Any guesses? Yeah, easy word is shard. So we group services together in shards. So obviously we don't have 3 services, but we group services in shards. Shards are replicated across data centers. The replication is async because we respect cap and we want to optimize for availability, right? The replication is bounded, so what that means is at any given time we know what is the in-flight data, and this amount of this information is used to reconcile if there's a failover. So you never lose your orders, but this information helps us that if there is a 2 second lag or a 3 second lag, helps us to go and replay things that we have in our logs. Users are mapped to shards, right? So there's no router here. Every user's app directly talks to the data center. This is an informed decision to avoid single points of failure again. This magic happens via DNS. So few users get mapped to certain shards, and this is a daily exercise. So we figure out or we predict hotspots, and then we try to load balance it across shards. This is more commonly called cell-based architecture, and it's come up on the tech radar recently as well. So the advantages is obviously higher scalability. We have million customers coming in every month, so we just throw hardware at the problem, and you buy more hardware, you scale horizontally. You have a reduced blast radius, so that means if things go wrong, not everything is not all customers are affected, right? So you can do DRs in a very contained fashion. So rather than moving 25 million customers from one data center to another, we just move the shard from one data center to another, so we can contain the blast radius, and it helps with better deployments. So that means you can do canary deployments. If you have a new feature, you don't need to expose it to the whole bunch of your audience. This works well with apps. If you release an app to the app store, you can dial up and dial down how many people see the new features. With backends, it's slightly more difficult because our feature needs to work with a lot of different external systems. So having shards help us do canary deployments, blue green and stuff like that. The second pattern which I want to talk about, I'm calling it always on, and this is on the front. The objective here is to give a delightful experience on the app even when you are driving to a tunnel, right? So we saw people making split second decisions and buying and selling stuff. What happens if you're driving through a tunnel and you want to manage connectivity? The key insight here is your phone has storage and has compute, right, which we leverage. So most processing happens on the app using local storage, and then there is basically sync between the front end and the back end. This entails complexity in both. So we'll look at the front end and then look at the back end. On the front end side, we use something called as MVVM, which is pretty common. We use room for our persistent storage. All our models are in DAOs, which lie in the SQLite database, and all the upper layers use those for showing views and for enabling the views that you actually see. Now the intelligence lies in the repositories. So once you ask for some data, each class can make informed decision whether I should show locally stored data or not, right? And these decisions can be intelligent. For example, if market closes at 3:30 and your positions won't change, then we can show positions from the local storage without even making an API call. We know that prices change multiple times in a second, so there's no point storing them or showing prices, right? So we can make informed product decisions, whether to show a blank screen, whether to show last known data, whether to refresh behind the cache serving, right? This we can make on a per domain decision using this app, and Room is really cool in enabling us to do this. So once you do this, there is some complexity at the back end as well, and most often you'll end up having things like this: background workers which try to process your request. Let's say order placement. Typically your API calls will return a 201 saying okay, done, and you'll pass it on to something like Kafka, right? The problems to solve in this architecture, for example, things like idempotency. What happens if your app retries, right? It need not be you, the customer, retrying. It could be an API retry on the front end. How do you ensure that we don't do $2 million orders instead of a single $1 million $1 million order that a customer has done, right? So we need trace IDs to be passed right from the app generation onto the exchange, the queue that we saw, for the idempotency to work, right? So that is tricky. Then making progress in a queue is tricky, right? You're processing messages in a topic partition, you come to a message where you're stuck, an external service which you want is no longer there. What do? So we have a boilerplate for all our consumer code with dead letters and retry queues. And the third and last pattern that we have is external distrust, is healthy distrust, especially of external dependencies, right? So we are a marketplace, right? We take your orders and give them to the exchange. So let's say this is your dependency X, not necessarily the exchange, and there is certain SLA that the external service provides you, right? In this case, it says 99% of the time I'm going to return in 200 milliseconds, and you know what your TPS is. Right. How do you ensure this request meet their SLA even if this thing goes down? Right. So basic idea is you have a per dependency thread pool. Thread is in quotes. I'll explain later. So that if this dependency goes down, the clogging is isolated, and if there are user requests which don't need this, they are not affected at all. Two problems to solve. How do you size the thread pool? You do the maths. So you basically you start with the dependency, you figure out how many retries you want. 200 milliseconds, if you do one retry, one user request is going to take max 400 milliseconds. Next, you look at your TPS. So you are going to promise 30 requests per second. So if you have 30 requests per second, each is going to take 400 milliseconds. The thread pool size is 12, and you add some nice buffer and make it 50, right? Most people, when they use thread pools, the basic mistake they use is they use defaults, or they put insane numbers like 500, which actually defeat the whole purpose of having a thread pool, right? So to key summary in the this pattern is do the math and don't make it fat. Don't make the thread pool fat. So my last section is on choices, starting with what languages we code in. We use Go for most of our backend languages. 3 reasons: simplicity, the runtime predictability that we have, and efficiency in concurrency. So a simple example of efficiency: so a Go stack is 2 KB, right? And most other languages, if you use threads, the stack is mapped to the OS level stack, which in Linux is 8 MB. So in 4 gig RAM, you can host 2 million Go routines and only 500 threads, right? So 2 million Go routines and only 500 threads. This allows you to be pretty creative with your concurrent programming without worrying about whether I'm going to run out of threads, file descriptors, and whatnot. So coding concurrent stuff is pretty fun in Go. If you have a function and you want to do it async, just put Go in front. And if you want to make sure that you get results from whatever is happening in the background, the constructs like select and timeouts really help you build it very cleanly. And as I said, it's fun coding in Go. For the rest of the stuff, we use Python for all our batch processing pipelines, and also stuff where we need a lot of ecosystem help. For example, we do a lot of rolling averages and matrix multiplications, where NumPy and Pandas is really helpful. On the database side, going fast, on the database side, we really like plain old SQL transactional database. The ACID semantics make programming simple. Modern SQL engines are actually very extensible, and they have really good features like columnar indices. So if you have like analytical group bys and stuff like that, you should really look at what your SQL engine offers before you start using a different database for it. We cache where we really need single digit millisecond stuff, and we use Redshift for a lot of the analytical use cases that we have. As I said, the go-to is always a SQL database, and engineers need to answer why they can't use it before they start leveraging other things. The last slide, cross-platform. This is a common question which I also get asked a lot: is how do we make sure that we build UI elements in a cross-platform way? So we tried Flutter and few other things which didn't work out. What really worked out for us is plain old WebView with something called as Svelte. The reason we like Svelte is because of server-side rendering. So if you have like an involved page, then you can render the most of the page at the server side and ship it. So the first time to load of the page is really fast, and then the JavaScript can also obviously work on the client side to give you the animations and stuff like that. So this is our test on our native front ends. We use native code where we need performance, and wherever we feel we can leverage cross-platform stuff, we use Svelte. So that's it. I'm at boot number 8 if you have any follow-up questions.
Thank you so much, Yati Sarup, for that. Let's give him one more round of applause. While we're setting up for the next talk, we would like to invite you to showcase your summit experience and win lovely prizes by getting involved in our social media contest. All you need to do is follow at Developer Summit on X, i.e. Twitter, and LinkedIn to stay connected. Share your summit highlights, insights, photos using the hashtag gids and hashtag Developer Summit. You can check out the contest details in your copy of the printed summit guide. Let's spread the excitement and make your participation unforgettable. For any session updates, please check the notice boards outside the hall. I would also recommend to you to follow at Developer Summit on X for real-time updates. You will find social URLs are on page 3 of the guide. And as always, if you need any assistance, we are here to help at the front desk at the main entrance. While you are in sessions, we also ask that you silence or turn off your cell phone so there will be no interruptions. All right. And our final keynote of the morning brings his 24 years of experience in the industry to discuss architecting for innovation. Please help me welcome Debasis Bhattacharya to the stage.
Hi, everyone. My name is Debashish and my colleague Anchit we are having 15 minutes. Our objective is to kind of continue where Rebecca left. She talked about a lot about Gen AI, building faster applications, the dilemmas and the bottlenecks that are there. We'll of course not repeat them. We bring in the Google Cloud point of view. We will be talking about Kubernetes. We'll be talking about the few of the announcements, the things that we believe that developers and architects like you can leverage this and take things into production quickly. And I mean production quickly. And at the end of that, Anchit would be taking a demo session, which again has something I believe will be very interesting for developers. And at the end, there are some goodies and other things that we'll be calling about the certificates and other things that Google is launching for developers like you. So very short time, let's get started. This is the first code commit of Kubernetes, June 6th, 2014, 10 years back. It's the 10th anniversary of Kubernetes. Wonderful moment. And this is the platform that has grown. 314,000 code commits has happened. 74,000 contributors have committed code here. What started as Borg inside Google today powers workloads for hundreds and thousands of organizations, and more than 7,800 organizations have contributed to the code. This is a wonderful moment. I thought to start with that. Kubernetes has evolved a lot from running stateless application Then it started moving into hosting stateful workloads. Then you are running hybrid cloud, edge computing, and today it is also running the most demanding workloads for your AI stack. AI applications demand very little different thing. These are modern application. It definitely demands a serious amount of scalability requirement. Imagine you make a particular um, uh, product go live and it is popular. The amount that particular application has to scale is tremendous. So you need a platform that actually helps you scale that way. Cost and performance. Inferencing is expensive if you don't do it right, and you have to balance between what is the performance you want to give to your end customer and how much you want to spend for it. Normally AI workloads are having a complex stack. It has number of frameworks, it has number of libraries, and hosting them into an environment has its own challenges. And then security and compliance. Last but not the least, your data is your data. Your data should not leave your VPC environment and should not be used to uptrain other models. So with all these concerns, we have always seen organizations trying to kind of enhance their application with the latest of AI, Gen AI, and there is a tremendous pressure on engineering teams of what platform to use, and should they go ahead with the right platform. We believe that your container management platform can run your traditional workloads along with your demanding AI workloads. We believe that you do not need to go ahead and reinvent the wheel and actually look at your container management platform to host all of these. We'll just quickly sneak peek into a few of the offerings, and as I said, the new announcements that we believe would help you tremendously. The container management platform that Google offers has primarily two offerings. One is Cloud Run, which makes running containers very easy on cloud. You are a developer, you are not a container expert, you just want to write code, and we provide you open source build packs, which takes your code, creates a container out of it, and deploys it into Cloud Run. The Cloud Run is a serverless environment which brings up and brings down your application, scales up and down as your traffic goes. With LangChain support on Cloud Run, you can see the continuous involvement and improvement that is happening on Cloud Run. I'm sure many of you would know what LangChain is. Today, Cloud Run is one of the easiest and simplest way of hosting your LangChain application onto executing platform. Here is a quote from a founding engineer of LangChain. I'll just be very interesting to call it out. We researched alternatives, and Cloud Run is the easiest and fastest way to get your applications running in production. Now, while we have been doing a lot of enhancements with Cloud Run and others, there was one particular requirement that came in. There is an ask that while LangChain integration is there, but there is a challenge of integrating with various services of Google Cloud or other cloud providers, how you do the tooling around it. There is a new launch that we did in the next event just a few weeks back. It is called the Cloud Run Application Canvas. This is backed by Gemini, and the objective of this particular tool is that you give your application requirement in natural language, and it can paint your application for you. It is much easier, and then you can go ahead and take it forward, integrate with other services. It also integrated with services like Firebase, hosting, Vertex AI, Memory Store, and others. Imagine what is the pace of application development would be if you are going to take this kind of route. And please watch out for this space. A lot of announcements are coming here. The next application platform, which is a very popular one, is the GKE environment, the Google Kubernetes Engine. It is the industry leading by scale. It has unmatched price performance, and it is easy to use. This is primarily while Cloud Run, as we mentioned, that you do not want to understand Kubernetes, you write your code, we have build packs, and it goes ahead and deploys. Kubernetes is the most way you can customize this particular Kubernetes environment, make your own environment and host it on Google Cloud and run. It gives you unparalleled performance, unparalleled option of bin packing that is possible directly in the console and makes it much more cost optimized than many other cloud offering that is there. A few of the announcements, very interesting one. I think in the initial keynote, it was mentioned about GPUs, TPUs, LPUs. One of the recent launches that came about the TPUs that Google launched is the TPU V5P. You can use that particular processor with GKE itself. One quote from character.ai who calls out that how their training of the models became much faster with GKE and TPUs together. Not only TPUs, there was a new announcement, again very interesting one. If you are using this heavy H100 GPUs, GKE and others support this A3 Mega processor. The A3 Mega is basically a next generation of instances with H100s that we provide. It provides 2x of networking performance between the nodes. When you're training large model, that is extremely important. So GKE not only has support for TPUs, CPUs, and the GPUs, and also the newest and the latest models that are coming in. One of the issues that you find when you are running large AI workloads on cloud is your images are large. It takes significant amount of time for the environment to load up. You know something called cold start. You have learned it from the Java days that if it's a big image, that is the imagine if you have a large model and it takes tremendous amount of time to load up. There's a new feature, very important one to note is the container image preloading, which makes the cold start time literally reduced significantly around 29x times. Another very important one. Normally, while you are running such applications, you keep your data in the object storage. Object storage, while it can scale and it is performing, but it doesn't have that amount of not like a block storage that is there. So often these workloads get into this latency of reads when you are going and training a model. So again, extremely important feature that is released called GCS Fuse Reading Cache, which really enhances the pace at which the read of this particular type of applications happen. I'll hand over to my colleague Anchit, and before that, it would be unfair if I don't mention about Gemini. Gemini is the best-in-class model released by Google. It is a multimodal model, and that means it can do text, images, and video together. It doesn't do it separately, and you would have seen the benchmarks that Gemini and the releases of Gemini. So I'll just take a moment to talk about something again, which was spoken about in the first keynote. You as a developer will experiment, and there is a nice offering that we get, which is called the Vertex AI Model Garden. It is a curated repository of Google's first-party model, third-party models, and open source models. And also we provide a tool called Auto Side by Side. You as a developer can choose a model from Model Garden and compare them, whatever suits for you, and there's a tool built in for it. So you don't have to go ahead and research. It hosts models that are present there. So one quick snapshot of the foundation models that we have. We are calling out Gemini 1.0 Pro. Gemini is in 3 buckets. The biggest model is called Ultra, the medium size is called Pro, and the other one is called the smaller one is called the Nano. The models that are released and GA today are available on the first row. There is one open model I'm sure you would have heard about is called Gemma. The Gemma is a 2 billion and a 7 billion variant, and again, there is a lot of tooling like Collabs, like Kaggle workbooks that are provided in the console itself. You can just go ahead and start using it and create the notebook and launch it and use it. There is about code assists. You would have seen a large amount of applications that are coming in to assist developers. My colleague Anchit will take a quick demo on it, and then I'll come back and talk about the new launch certificates which you can leverage here. Anchit.
Hello, everyone. I'm Anchit. I'm a customer engineer at Google. So, quickly in the next 4 minutes, I'm going to show you what Google is doing, or basically how Google is trying to help make a developer's life easier, right? How many of us are developers here? Quick raise of hands. Yeah. So it's. I think this would be very much close to your heart. So imagine in your software development lifecycle, right? What are some of the things you need to do when you're told to build an application? First, you would need to create an infrastructure or architecture diagram of your application, right? Application architecture diagram, infrastructure architecture diagram, deciding what tools to use. Am I right? So think you have already created an architecture diagram. You want to share it with your internal team. But before sharing it with your internal team, you want to get some more information of if it can be made better, right? You want to understand if there is something which can be better here, if you are missing anything, any security aspect, any HA aspect, etc., etc. So how would you do that? Simple. Go to gemini.google.com, select the model. Go to gemini.google.com, select the model. Since it is multi-model, you can post an image, PDF, video, whatever, and ask basically what does it think about it. Is there any enhancements which can be done? Yeah, so it'll give you precise in context answer specific to your input. For example, here I have entered my block diagram, right, and it has told me what needs to be done, like in load balancing. In I should include monitoring, logging. I should have backup recovery done, or have I enabled SCC command center or not, because it couldn't find SCC in the block diagram, right? So this gives us a good head start and reduces a lot of time when we are trying to build it. Next, I have my application set. I have my block diagram set up. I have chosen Google Cloud to deploy. Next, what do I need to do? Write the code, right? So to write the code, what I'll do, I'll quickly go ahead, open my favorite IDE. I like, which IDE is this? Yeah, I like VS Code. And in VS Code, we have integrated Gemini as a plugin. So see the possibility of having an LLM integrated to your VS Code. Now, what I'm going to do is, since the time is less, I'll simply write a prompt to create a fast API for a service which to get a customer based orders of a customer, right? So I simply ask Gemini to do it, and since it is directly integrated to the ID, I click on plus. I have the code here. Now, of course, might not be the best code in the world, but this is a good start instead of having a blank screen. Am I right? So you go ahead, see the code, debug it, and you run it. Imagine this code is not written by you, but you have inherited the code, which happens a lot of time. So what you need to do is, again, just select the function, click on the button, explain this, right? It's going to explain it to you what this function does. Not just that, you have written the function, you want to do testing on it, right? Again, the next step, select the function, click on it, generate unit tests. So now your code is ready, your unit test files are ready, you are testing it. Next thing is you want customers to use it, or basically your stakeholders to use it. So what you need to do, you need to write a document on it. Am I right? And how many of us likes to writing documents of the code which we have written? So again, I'll outsource this work to Gemini. I'll ask it to create the API documentation. Now, it knows what code I have written because it's already open in the console. It will give me in context document. It will give me the endpoints, get port, post port, whatever it is, what the response is expected, what is the input is expected, output is expected, right? So one of your tedious tasks has been given it to Gemini. You're happy about it. Application done, deployed, testing done. So while testing, testing not done. While testing, you hit some errors. What would you do? You'll go through the logs, right? Since I'm using Google Cloud, I'll go to the logging console. I'll go to the logs explorer and I see tons of logs here. What would be my next step? Read each of the logs, try to read the documentation, understand what it is, or select the log, ask AI to explain it. Not just this, it'll explain me the log in context of the other metadata. I can also ask it to tell me the next flow. I mean, how to rectify it. Imagine application deployed, all logs gone. All errors gone. My analytics is set up. My data is moving to my analytics platform, which is BigQuery. Now, how many of us like to write SQL queries? Okay, so I see a lot of people do like to write SQL queries, but still, it's a tedious task, right? You want someone to see the table, you want someone to understand the schema, and what you can do is simply write the query in a natural language. For example, this is a data set from Stack Overflow. I'm simply asking it to list top 10 rows based on score from this table. What is this table? This is the table which I have opened on the left hand side. So it knows the schema. I have the query now. I insert it. Hopefully it runs. It's not giving me error, so it did run. Next, imagine if you have inherited this. Again, select it, ask it to explain. If you see, everything is happening in context, right? So quickly, I just went through your daily life, right? What you do and how Google is helping you simplify it by its tools, right? So they're
Thanks,
welcoming
Anchit.
you back.
Thanks, Anchit. I think you can give it a try and look at Google Code Assist. Include it into your choice of editor. The most important part is there. I'll take one more minute. If you can go to the next slide. So in this particular event, we are launching a few certificates. Very important. I'm sure you would have liked seeing all of these things, but something in your mind that how do I learn about it? Can I get some amount of accreditation for it? I think these are the few slides. One more minute I'll take. I'm between the coffee break and this. So this is a on-demand online program and certificate that Google has launched. Those are the certificates that are there: Google Cloud Cybersecurity Certificate, Google Cloud Data Analytics Certificate, and Google Cloud AI Skill Batch credentials. These are made available free for higher ed students, government organization, non-profit work people at all. But my request is that please do go and visit the Google Cloud booth there. There are multiple options of taking this for professionals like you. This is extremely valuable. My request is to go to the Google Cloud booth and see them. Thank you. That's all we had.
Thank you, gentlemen, for your presentation. We will be taking a coffee break now. All sessions will be starting at 11 o'clock. Please refer to page 2 of your summit guide for a map, so it'll be easy to locate where your next session might be. As always, front desk is here to help. Thank you so much, and we'll see you back at 11.